Good afternoon, I am Mr. Ish. Thank you for joining me for this video here on an interesting chemistry concept relating to gases. We have 4 liters of nitrogen gas and 5 liters of hydrogen gas which react in a reaction vessel under STP, standard temperature and pressure. We're assuming everything here is following ideal gas behavior. We have to find the pressure and the volume of the product gas that is produced. What are our items we know? 4 liters of nitrogen gas, 5 liters of hydrogen gas under STP. You have to start with this question with what you know in terms of a reaction. If you don't have a reaction, you can't do anything. You have nitrogen combining with hydrogen gas to give you a gas which is called NH3, ammonia. Now that you have a reaction in terms of a equation, you have to balance it. You have 2 nitrogens, you gotta have 2 here. Now you have 6 hydrogens and you can put a 3 over here, and your reaction is balanced. And now keep in mind this important point: standard temperature and pressure. Temperature is always 273 Kelvin, pressure is always 1 atmospheres. A very important factor which will come into play over here is this: 1 mole of any gas under standard temperature and pressure will always occupy 22.4 liters of space. So you have to remember that conversion factor, it will come into play. 1 mole of gas occupies 22.4 liters under ideal gas conditions. You have to determine what the limiting reagent is, because nothing here is infinite. Everything here is finite. We'll do everything here for nitrogen, we'll do everything for hydrogen. This conversion factor will come into play in terms of you determining which one is the limiting reagent, because we have only volumes given over here. Let's look at nitrogen. We have 4 liters of nitrogen. You're going to multiply it by this conversion factor. You have 1 mole of nitrogen gas which occupies 22.4 liters. Now look at the same conversion in terms of hydrogen gas. You have 5 liters of hydrogen gas and you have this 1 mole of hydrogen gas occupies 22.4 liters. These are diatomic molecules, N2, H2, they're diatomic, meaning they're made of 2 atoms, but they're still a single entity. Look at each of these and this will tell you the moles. The one with the smaller moles is your limiting reagent. You'll do for nitrogen 4 divided by 22.4. You get here 0.17857 mole nitrogen gas. Now let's do the same thing here for hydrogen. You'll do 5 divided by 22.4. You're getting here 0.2232 mole H2. Which one is the limiting reagent? It's this one, because it's present in fewer moles, or it has less quantity in terms of its reaction. This right here will determine how much of that will be produced, and you'll have to use another factor label procedure here: 0.17857 moles N2 times. This reaction generates 2 moles of NH3 for each 1 mole of N2. And this right here, by means of this, you'll see this will cancel out. You'll end up having an answer here in terms of moles NH3. All you have to do is this multiplied by 2. 0.17857 times 2. You get here 0.35714 mole NH3. But does this answer our question? No, it doesn't. It helps us answer our question because we still have to determine the pressure and the volume. Utilizing this, we can very easily determine the volume of our product gas, which is NH3, volume of ammonia. You're starting out here, 0.35714 moles NH3 multiplied by, under ideal gas, each gas occupies in terms of its volume 22.4 liters per mole of that gas, mole of NH3, and we're talking about 1 mole here. These will cancel out. You'll always have ending up here with an answer in terms of liters. You'll do 0.35714 times 22.4 and you'll get a good answer here, and it'll be 8 liters, and that'll give us the volume of our ammonia gas that's generated, 8 liters. Now the only thing that remains is to determine the pressure, and it's not hard. You know the equation here is PV is equal to nRT. You know R over here is equal to 0.0821, your universal gas constant, 0.0821 liters atmospheres divided by moles Kelvin. If you want to solve for P, just take the V on the other side, nRT over V, and it's not hard. We can do the pressure calculation right here, everything on the calculator, and we should get here a 1 atmosphere answer, and we will. We're going to do nRT divided by V to give us our P value, the pressure, and let's do it. The N value is right there, 0.35714 times your R, your gas constant, 0.0821 times 273. divided by 8 liters of volume, and we're getting one atmosphere. And our answer is good. Everything here is being kept and maintained at standard temperature. Pressure, STP, the volume and the pressure have been determined. Why is the pressure not increasing in this chamber? Because you have a reaction here at equilibrium. As the reaction proceeds, these things combine to generate that, but after some time this starts decomposing and going backwards. So you have a forward and a reverse reaction which ends up achieving equilibrium. You have a reaction going towards the right in terms of the production of this, and the reaction going to the left in terms of the decomposition, which equal each other. Hence the pressure doesn't increase in the chamber. You are keeping everything here at 1 atmosphere, and this value here confirms that everything here looks good. The moles, the volume, the pressure, we're done with this question, and that's it. Thank you for watching. Have a good day.